Hello students, in today's class we will see a second order system's response to unit step input if the system is a underdamped system. Okay, we know that the second order transfer function is given by omega n square divided by s square plus 2 zeta omega ns plus omega n square. Right? Now what we claim is, we claim that it is an underdamped system. So when the zeta varies between 0 and 1, last class we have seen an undamped system where zeta was equal to 0. Now we are going to see a system where the zeta is between 0 and 1, and this is called as an underdamped system. Okay, right. Now we have to find out the unit step response for this. So C of S is equal to R of S into omega n square divided by S square plus 2 zeta omega ns plus omega n square. Right? So we know that for a unit step input R of S is equal to 1 by S. So 1 by S into omega n square divided by S square plus 2 zeta omega ns plus omega n square. Right? So how to split it using partial fraction method? This is equal to A by S plus Bs plus C divided by S square plus 2 zeta omega ns plus omega n square. Right? So now this can be written as omega n square is equal to A into S square plus 2 zeta omega ns plus omega n square plus S into Bs plus C. Okay. Now A square plus 2 zeta omega n A into S plus A omega n square plus B square plus CS. Okay, and what about left hand side? Left hand side we have omega n square. This is after taking LCM, right? Okay, now we have to equate the coefficient of S square, S and constant. What will happen when we equate the coefficient of S square? Equating coefficient of S square. What do we get? Here left hand side it is 0, right hand side A plus B. Right? So A plus B is equal to 0, which means A is equal to minus B. Okay. Now we have to equate the coefficient of S. What do we get? Again left hand side is 0. What about right hand side? 2 zeta omega n A, right, plus C. Am I right? 2 zeta omega n A plus C is equal to 0. Right? So which means C is equal to minus 2 zeta omega n A. And what will happen when we equate the coefficient of constant on both sides? Left hand side we have omega n square, and what about right hand side? We have just A omega n squared, right? So A omega n square is equal to omega n square, which means A is equal to 1. So when A is equal to 1, we know that B is equal to minus 1. And what about C? C is equal to minus 2 zeta omega n. Right? We need to substitute all these in this expression. So what happens? C of S is equal to 1 by S, right? Then what do we have? Bs plus C. What is B? B is minus 1. So minus 1 into S is minus S, then minus 2 zeta omega n, right? So we can take this minus outside here. Wait. Minus S minus 2 zeta omega n divided by S square plus 2 zeta omega ns plus omega n square. Am I right? Now you can take this negative sign outside. So what happens? 1 by S minus S plus 2 zeta omega n divided by S square plus 2 zeta omega ns plus omega n square. Right? We know that we have to find out Laplace inverse in order to get C of t. But see here, for 1 by S we know the Laplace inverse is 1. But what about this term? This is quite a peculiar one and we cannot find out the Laplace inverse of this, right? So in order to make it easier for getting the Laplace inverse, we have to do some magical tricks to this expression. Okay, let us see what are those magical tricks, right? So what happens? We'll have this 1 by S as it is, right? So numerator, you can rewrite this 2 zeta omega n as S plus zeta omega n plus zeta omega n, right? Is there any problem? No, right? So S plus 2 zeta omega n is nothing but S plus zeta omega n plus zeta omega n, right? What about the denominator? Denominator, we can add and subtract zeta square omega n square. S square plus 2 zeta omega ns plus omega n square plus zeta square omega n square minus zeta square omega n square. Okay, will this change the denominator? This won't change the denominator because we have just added and subtracted, right? Okay, see later on we'll see why we have done it like this. Okay, now what will be the next step? See, next step, the denominator, you just take these three terms, okay, and rewrite. What happens? Right, 1 by S minus S plus zeta omega n plus zeta omega n divided by S square plus 2 zeta omega ns plus zeta square omega n square. I am just rearranging, okay, plus omega n square minus zeta square omega n square, right? What is this? S square plus 2 zeta omega ns plus omega square zeta square. This is nothing but, it is of the form S plus A the whole square, right? So what is the A here? Zeta omega n, right? So it is nothing but 1 by S minus S plus zeta omega n plus zeta omega n divided by S plus zeta omega n the whole square. What is S plus zeta omega n the whole square? S square plus zeta square omega n square plus 2 zeta omega ns, right? Now, what about the remaining term? Omega n is common, omega n square is common, 1 minus zeta square, right? This omega n square into 1 minus zeta square is nothing but damped frequency, omega d. Omega D is called damped frequency. Frequency with damping factor included. Okay. So when you rewrite this omega n square into 1 minus zeta square in terms of omega d, what happens? It becomes omega d square, right? So C of S is equal to 1 by S minus S plus zeta omega n plus zeta omega n divided by S plus zeta omega n the whole square plus omega d the whole square. Right? Till this you are clear? We'll rewrite this one. Okay. So C of S is equal to 1 by S remains as it is. See, now we have S plus zeta omega n plus zeta omega n, right? So we'll take these two separately and that separately. Okay. So what will happen? Minus S plus zeta omega n divided by S plus zeta omega n the whole square plus omega d square, right? Minus zeta omega n divided by S plus zeta omega n the whole square plus omega d square. Am I right? I have splitted this into two. Okay. So now you can see this is of the form S by S square plus A square. What about this? Cos AT, right? When you have another term, this leads to e power minus zeta omega nt, right? So that term will lead into a cos term, right? But what about this side? When you want this to become a sine term, you must have omega d here, right? But instead we have zeta omega n. So what can we do? You just multiply and divide by omega d. Okay. So we can rewrite this as 1 by S minus S plus zeta omega n divided by S plus zeta omega n the whole square plus omega d square minus zeta omega n divided by omega d into omega d divided by S plus zeta omega n the whole square plus omega d square. Right? So this is of the form. Now we will take C of t is equal to Laplace inverse of C of S. Okay. So what will happen? C of t is equal to 1 by S will become 1 minus what about this term? E power minus zeta omega n t because of this S plus zeta omega n t term. Okay. Then what do we have? It is of the form cosine function, right? Cos omega dt. Right? And what about this term? Here this is a constant which is nothing but zeta omega n divided by omega d into sine omega dt. Right? Now we can rearrange this. What is omega d? We know omega d is nothing but omega n root of 1 minus zeta square, right? We can substitute it there. 1 minus e power minus zeta omega n t. Sorry, here also you have this e power minus zeta omega n t. I have left out, okay? Minus zeta omega n t because we have this term, right? Sorry, I have left out. So we have to be very careful when writing the expressions, right? So zeta omega n divided by omega d e power minus zeta omega n t, then you have sine omega dt, right? Okay, now cos omega dt minus zeta omega n divided by omega n root of 1 minus zeta square e power minus zeta omega n t then sine omega dt. Am I right? Now see, this e power minus zeta omega n t is common and this omega n gets cancelled, right? So what happens? This is nothing but 1 minus e power minus zeta omega nt into, you take this here. So you can take this root of 1 minus zeta square also as common outside. So what happens? Root of 1 minus zeta square cos omega dt suffix. Since minus is taken out, here we have plus term, right? Minus is taken as common. Now what do we have inside? Zeta sine omega dt, right? So here we have it to introduce another thing. What is it? Assume zeta is equal to cos phi. Okay, assume zeta is equal to when you assume zeta is equal to cos phi, what is cos phi? Adjacent by hypotenuse, right? So in a right angled triangle, this is zeta and this is nothing but 1. So what about this one? It is root of 1 minus zeta square, right? So what is root of 1 minus zeta square? That is sin phi. Assume this to be phi. So sin phi is root of 1 minus zeta square, right? So we can substitute. So C of t becomes 1 minus e power minus zeta omega nt divided by root of 1 minus zeta square into, this is cos phi, sin phi, right? Sin phi cos omega dt plus cos phi sin omega dt. These assumptions are separate, right? Let me just rub it off and write sin omega dt, right? What is this? Is of the form sin a cos b plus cos a sin b. What is that? It is sin of a plus b, right? What is a? Phi, and b is omega dt. So sin of omega dt plus phi. So the C of t expression becomes 1 minus e power minus zeta omega nt divided by root of 1 minus zeta square sin of omega dt plus phi. Okay, this is the final expression.